Hello class. This week we're talking about Chapter 24, the Internet. We're going to talk about how it works, how to connect to it, how to use certain Internet application protocols and what those are, and how to troubleshoot an Internet connection. First, let's talk about how the Internet came about. The Internet came about when several governmental agencies and universities worked with something called DARPA, or Defense Advanced Research Project Administration, and they wanted to get the government agencies communicating as well as the universities being able to share research a lot easier. Well, they came up with this idea of internetworks, being able to have connectivity between the computer systems of these universities and governmental agencies. Therefore, the Internet was born. So, but it doesn't explain how it works. So how does this Internet work? Well, you connect to your ISP, your Internet Service Provider, and they give you an IP address, and then you connect to the Internet. But how do these ISPs get their Internet connection? They do these through their own Internet Service Providers called tier providers. These tier providers have different levels. There's a tier 1 provider. These are in large metropolitan areas, and they basically are the hubs for the Internet. So places like Chicago, New York City, Los Angeles, Atlanta, they have what are called network access points, where these large routers and switches move all this information all over. Then you have tier 2 providers. These are smaller regional area companies that pay the tier 1 providers for the connections and then give it to the regional area. So like Indianapolis, Lafayette, stuff like that. Then there's tier 3, which are even more regional. So say Comcast wants to service a certain section of Lafayette. Well, and then you have your Internet Service Providers specifically. So this is how we get our interconnectivity between all the different cities, is through these tier providers. There's more to it than that, but again, that's beyond what we're really needing to talk about. Go ahead and read this on page 1090 and 1091. But still, how does the communication flow across the Internet? Well, this communication flows just like it would over a local area network with TCP/IP. This is the language of the Internet. It still uses IP addresses and DNS to be able to move information between here and there. So these Internet Service Providers, what they do is you connect to it, and with the DHCP, Dynamic Host Configuration Protocol, you get an IP address. And then you go through your default gateway, which is your home router, and then you go to the Internet, and then through the tier 1, 2, and 3 providers. So there's different ways, though, to connect to the Internet. One of those ways is dial-up, using modems. Now, dial-up isn't the only thing that uses modems. DSL, cable, ISDN, those all use modems. But dial-up is one of the first ones to be able to connect. Now, a modem is just an abbreviation. It stands for modulate and demodulate. What does that mean? Well, the phone lines have an analog signal, but your computer only knows the digital signals, which is the square blocks, the ones and zeros. Well, you have to be able to translate that. And that's what a modem does. It's just a translator between the analog signal and the digital signal. Does that make sense? Okay. So you have your dial-up modem. This connection works very slowly because it works over the telephone lines. 56 kilobits per second, or kbps, is the rate at which dial-up can occur. But you almost never see the maximum throughput on this. You typically see anywhere between 36 and 48K for a dial-up connection. They're just significantly slower. What, where would you still see a dial-up connection today? You would still see a dial-up connection today anywhere you would not have easy access to any other type of internet connection, be it satellite or cable or or DSL. So like way out in the country or even in the mountainous regions, you might see dial-up connections. Wherever you can get a phone line, you can get a dial-up connection. These speeds are regulated by how good the phone line is, as well as how fast the modem is. If you have the fastest modem, which is what you would have today, 56K, and you had a good phone line, you would probably get about a 48 to 50K connection. If your phone line was somewhat staticky or degraded, you would probably see closer to a 22 or a 36K connection. So as you can tell, that's good for browsing the internet, but not much more. You can't stream media, you can't do very good downloading, you can't even really do any gaming over it, especially with the games today. There's different other kinds of connections that can go over phone lines. One of those is called ISDN. ISDN stands for Integrated Services Digital Network. And the way this works is you take the same phone lines and you bundle them into pairs and more than 2 or 3 lines, and you get what's called a trunk. It's just like a tree trunk. And the fact that you have your branches and then your trunks where those branches come together. Well, what this allows it to do is use the same 56K connections, except bundled into multiple connections. So now you get like 56 times 2 or times 3 or whatever, up to 24 pairs, or up to 24 phone lines is what I mean. And these are called a basic rate interface, or BRI. The limitation here is you have about 18,000 feet to be able to get there. So you're just limited on the distance of an ISDN connection. It's not going to be nearly as fast as a DSL or a cable. The fastest BRI connection is a T1 line. That would be about 1.544 megs. So 1.5 megs per second. Okay, so you still have some things that or you're still limited on speed. It isn't always on, so therefore it's a broadband connection. But this is not going to be one of those things that you're going to go and they're expensive too, because the phone company has to bundle all those together and get them to your premises. Another type of connection is DSL. We're more familiar with this in cities type areas, so metropolitan areas, as well as maybe some smaller towns. DSL connection, digital subscriber line. This is still working over a phone line, but there's a new way to make the connection that allows you to have voice at the same time as your data. It works through a type of encryption to be able to have this communication go at the same time. There's multiple different types of DSL. You can get anywhere between 768K to 10 meg today is what you're looking at for DSL. Again, you still have the 18,000 feet limit between your premises and your phone company's carrier office or CO. So you still have a length limitation. Cable, on the other hand, you have a longer length as well as speed. You can get faster speeds. The slower cable connections are anywhere between 1 and 10 megs, and then you can get different faster cable connections that can even go upwards over 100 megabytes per second. This is pretty fast. This is just like a LAN connection at 100 megs, but to the internet. So you have the cable, which is over a coax or fiber, and you can get this straight to your premises. Or so you have premises site fiber. We're going to talk about that in a second. So then you have your LAN, or your local area network connection, which can go through any one of these types of connections that we just talked about, ISDN, DSL, cable, to get to the internet. your LAN connection shares all of your different devices over to a single connection for the internet. Same thing as your 802.11 wireless. And now you have, like I said, we talked about fiber a little bit. Fiber is a newer type of service that's coming around. It's faster than DSL and can be faster. Also, is faster than cable. You have multiple different types of fiber connections. One is fiber to the node. So if you have a small geographic area like a subdivision or a neighborhood, and you get fiber centralized there, and then you split off like a spider web, that whole area becomes a node, and they share that single fiber connection. Or you can get what's called fiber to the premises. That's basically fiber to your business or home. And you're going to have that single dedicated fiber connection. Very, very quick. Also very, very expensive. You can get speeds up to gigabits per second with fiber. So the book says certain speeds, but today it's a little bit quicker. Or not a lot bit quicker. Finally, well, not finally. Next you have a cellular connection. Cellular connections is basically like what it says. It works over the cell phone network. So your different telephone providers, like AT&T, Verizon, Sprint, have their cell phone towers. And you can connect to these different towers wirelessly with a cell phone card or your mobile device, like your iPhone or Android device. These work at 2G, 3G, and 4G speeds. So you're going to have to pay for your data plans to be able to connect to these. So your downside here is cost. You can do a lot with these types of connections. They're very mobile. You don't have to stay at one location. Finally, you have satellite. Satellite is for those really remote locations that you can't even get dial-up. Satellite is subjective to terrain and weather conditions. Weather conditions can really hamper a satellite connection. You have decent speeds with satellite connections today compared to where you used to be, but you have a lag between your ground satellite dish and the satellite up in the sky. You have about 7-second lag. So it's what's considered asynchronous transmission. So you have some issues with things that may require, like gaming, quicker speeds. So, how do we connect to the internet? Well, you have your home router. Your home router can contain your routing device that allows you to connect to the internet, your switch, and a wireless access point to give you Wi-Fi in the home. In the lab, we're going to go ahead and talk about how to configure a router and all these different aspects. So you can set your different areas in your router as long as your ISP has given you access to this. You can change your username and password to log into the router. You can set your IP static. That's subjective to what your ISP needs you to do. You also may need to update your firmware. You can do what is called Windows Internet Connection Sharing. You have your home router and you put it through a single computer, and then you share it through the computer to other devices. This used to be utilized a lot with phone and modem connections. Today, mostly you just connect via Wi-Fi. So Windows Internet Connection Sharing is not used as much today as it used to be. Now, how do we separate all that traffic? You have your email, you have Google Chat, you have gaming, you have all these different types of applications that use the internet. How does your computer and the server on the other end know what you're going to be doing with the information? These are what are called Internet Application Protocols. We have multiple different kinds. We have World Wide Web, so HTTP and HTTPS. We have email, which is POP3, IMAP4, and SMTP. We have Telnet and SSH, which are ways to configure different devices. You're mostly using like a command line interface and console. You have FTP and SFTP, which is SFTP is just secure FTP, file transfer protocol. This is a way to get files to and from a different location. We have remote desktop, and you have your VoIP, so voice over IP. So let's talk about some of these. World Wide Web. This can operate in one of two ways. It can operate non-secure, which is going to be port 80, or secure, which is usually either port 443 or 8080. All of these different ports you can see how they are utilized on page 1116 or 1116. These are all very commonly used protocols. So, how do we configure our different applications to do this? Let's look at Internet Explorer. On page 1117, it talks about how to configure Internet Explorer. This is used for setting your home page, setting whether you can default to a secure connection or non-secure connection. I always recommend a secure connection if it's available. That way your traffic is encrypted and you can pass your username and passwords without someone else getting a hold of that. You can configure other web browsers much the same way. You typically go through settings and then options, and then you can go through and configure different browsers. Email. Email can be set up several ways. You can do it through the web browser as long as it's supported. So Google, Hotmail or Outlook, you have Yahoo Mail, you have your different internet service providers based emails. A lot of those can be configured and used through the web browsers. You can also have an internet or an email client. So you have Outlook, you have Thunderbird, you have other different types of email clients, including on your phone. So you have your Mac, your Apple Mail. So all of these can be configured. These will typically be using the different ports in World Wide Web protocol. You have POP3 or IMAP4. What POP3 does is it will pull the email down from the server and then store on your local device. IMAP4, what it does is it just creates a mirrored connection to your email server. That way your email stays on the email server, but you also have a copy on your device. That's the connection I almost always recommend. That way, in case you ever delete something or your device crashes, you never lose all of your email. SMTP is the way email goes out. So Simple Mail Transfer Protocol. Definitely highly recommend reading on that. So that way you know if you have email issues, you know if it's incoming, you're going to be looking at POP3 and IMAP4 issues, or if it's an outbound issue, like you can't send email but you can receive it, you're looking at an SMTP issue. FTP, or File Transfer Protocol. This is used to transfer files through the web. You can do it through the browser. It's still a form of FTP. Read on this on page 1124 and 1125. Telnet and SSH. Typically you won't use this unless you're remoting in to a router or switch at a console or command line level. These connections can be encrypted, and I highly recommend it because you're passing very sensitive information over them. Voice over IP. Voice over IP is a newer protocol. This is one where we do Skype, stuff like that. So Skype, and there's Cisco telepresence, and then also your newer VoIP phones, voice over IP phones. These all use a lot of high bandwidth traffic, but they need something what is called, they have something where they can deal with something called latency. And this is when you start hearing the breakup in the phone line. Latency is when it takes an extended time for one piece of information to get to another. So VoIP is very concerned about latency. You typically have to keep that at a higher priority for network traffic to keep it going faster. A remote desktop is exactly what it says. You can remote into another Windows computer and take control of it. Network administrators and systems admins are typically ones you'll see do this. Sometimes help desk people will do it to help someone else. But it talks about different programs on 1129 to be able to do remote desktop. It can be very helpful if you're trying to help people from a distance, or if you're not in the same building. That way you can continue to help them and not have to travel to that location, and it gets resolved quicker. If it's a hardware problem that is on the other end, you will not be able to troubleshoot that via remote desktop. Not typically. Just because of the fact that the machine is typically down. So just keep that in mind. Now, how do we secure these different types of connections? Especially if it's sensitive and private data. Something that you can use between yourself and another network is called a virtual private network, or VPN. This is a way to route information through the internet in a secure manner that's encrypted very heavily, and it provides a point-to-point connection between you and your other server on the other end. This basically makes your remote computer, the one that you may be on in a satellite office or even Starbucks, seem like it's sitting actually there on the network wherever you may be, whether it be Chicago, LA, Indianapolis, Lafayette. That way you can continue to pass traffic in a secure manner. How does it do this? Well, you have something called point-to-point tunneling protocol. Point-to-point tunneling protocol is, just like it says, it takes from one point to another, and then it creates this tunnel, just like you would underground. And then if you're above ground and you're looking at it, you don't see the actual tunnel. But it creates this tunnel in the internet for you to have this private connection, and it keeps all this information encrypted. It's very challenging to break into a VPN. So what kind of other support applications do we have for the internet? Well, there's something called LDAP. LDAP is Lightweight Directory Access Protocol. This is how you get your usernames and passwords. So whether it be with Microsoft Active Directory, or at school, or when we were on Novell, that's still an LDAP type utility. This allows you to be able to pass your usernames and passwords securely in your local area network. That way somebody can't just sit there and find out what your username and password is. Then you have SNMP. SNMP is Simple Network Management Protocol. And all this does is allows someone like a network administrator or a systems admin to be able to monitor their different devices. Server Message Block isn't really an application, but it's something where Microsoft used to use it to be able to pass some older traffic. So really, it's not really even utilized today, except in Linux type applications where you're trying to connect from one Linux computer to a Windows computer and vice versa. So how do we fix these things if they ever break? How do we know what's broken? Well, one way you can do is you can use monitoring services that you can set up yourself or pay for. And these monitoring services watch the different protocols and see what may be transmitting to whom and what the quality of that transmission is. But to troubleshoot your internet connection, first thing you have to figure out is if the issue is a hardware issue or a software issue. If you're having an issue with limited connectivity, so say if you're at your home and it looks like you get an IP address, but it's not your normal IP address. So you get this limited connectivity error, and you get a 169.254.0.16 address. Looks like you have an internet address. Really what it is, it's called an APIPA address. This is a default address if you can't talk to a DHCP server. If you can't talk to your DHCP server at your home, this is typically just your router. You may need to reboot your router. If that doesn't fix the issue, and it's like a hard connection, like a wire, then you may have a bad cable or a bad network card. If it's wireless, you may have a corrupt network wireless driver, or you may have just a bad connection to your Wi-Fi. You may be too far. If you can get an IP address and you can't get to the internet, you may want to check your DNS. The way you do this is you can actually flush. You may have a bad DNS entry. You can flush all your DNS entries. There's nothing wrong with this because it builds this on the fly. So on page 1138 it talks about this. Now if you can get to the internet but it seems very slow, you may need to see if the issue is your router or if it's past your router, if you may be having a lot of traffic in your area. You can use ping, traceroute, to see what kind of connections you have between wherever you're trying to go and see where the holdup might be. Another thing you might need to do is contact your internet service provider and see if there's an outage in your area. So, this is how you can start troubleshooting your internet connections. So let's go ahead and get started on this lab. See you in a bit. Hello class, and welcome to the week 12 lab on the internet. We have our 3 sections in our lab as we have in the previous labs. So section 1 is terminology. Section 2 is going to be router configuration, which is a simulation. You're not going to get physical routers. And section 3 is scenario. So section 1 is our terms and terminology, which is basically our terms and definitions. We've done this all school year, so you guys pretty much know that you can use any resource to get the definitions for each of these terms. Section 2 is you're going to go to this link here, and it's going to lead you to a simulator, and then you're going to answer the following questions. So the link, just to be clear, is http://www.voipproblem.com/emulators/netgear with a capital N /WG/U624 /index.html?interface equals WGU624. And then you go down and go through the simulator and answer the questions. And then when you get to section 3, it's going to be a short answers. You only have 5, and they're worth 3 points each. Let's go ahead and step through the simulator. So much like last week with wireless networking, you're going to log in, and this is the screen you're going to see. The basic setup is on the left side is the menu system. The middle is the content, and the right hand side is it's the assistant or the help screen. So you can actually resize these so you can see more. See, just like that, just put the mouse over and drag it over left and right. Okay, so let's look at basic settings. Under basic settings, you're going to be able to look at different things here about the account name if needed, because some internet service providers require account names. Your internet IP address, you're typically going to leave this as dynamic, but sometimes you can set static, especially if you're a business. Your DNS information and your router MAC address. If you notice here, you can actually manually set up your router MAC address. Then, if you tell, this has wireless built into it, so you can actually see your wireless settings. Your region here is set to France. Normally you would just set it to USA. Wireless G settings, same thing. Just set that to USA. And then you can always set up your WPA passwords and stuff like that. Content filtering is a new section for you guys. There are no logs because content filtering is not set up. But content filtering allows you to be able to tell what sites you can go to. So you can see here block sites. You can block by keyword. You can block certain services. Read on the right side here what this does and what block service allows you to do. And you can schedule how often, when this blocking is in effect. And then if somebody, you can also try on emails. notifications. So that way, if you want to send an alert when somebody tries to go to a blocked site, you can get that notification. Maintenance is an important section. This tells you your firmware version, your internet port, MAC address, IP address, all this information here. Stuff you've learned from the wireless networking lab. Attached devices means this is going to be for what device is physically attached. So it's getting an IP address from the router. Backup settings, you can save a copy of your settings. Set a password for a router, highly recommend it if for home routers and business routers. And this is where you would upgrade your router, in your router upgrade. Then you can go to the advanced settings. You can do more stuff here. So you can extend the range by setting to max settings, or you can reduce the range. Same thing for the G. Typically, you will want to disable SSID broadcasts in a home network only because of the fact that it's more secure. You'll have to manually set up, and somebody can't just hop on your network. It's another level of protection. Port forwarding. Apparently, this one does not have anything for port forwarding on there for you to look at. WAN setup. What WAN is not wireless, but wide area network. So this is your internet side of your router. Look at what DMZ is. DMZ stands for demilitarized zone, but it's where you can basically set a server so way it sees all the ports and everything is forwarded for the server to get to the internet. LAN IP, this is where you set up your DHCP server in your router. So you can actually see the default here is you're going to typically get about 179 addresses. You can extend or reduce that. Dynamic DNS. Look up this information here about what Dynamic DNS does. It's very helpful if you're going to be hosting a website on your own, inside your own network. Static routes is exactly what it says. The router is determining the traffic, and you're telling it where to go versus what the router is wanting to do. Remote management, so you can remotely manage your router from outside of your network. Can be very dangerous if not set up properly. And then universal PnP, or plug and play. And then you have your web support, your knowledge base, and your documentation. And that's pretty much it. So, if you have any questions on this lab, please feel free to go ahead and get a hold of me via the email that's right here in the upper right hand section of the screen, or you can get a hold of me in chat. Otherwise, good luck. Okay, well, that was some of the lab, and if you have any questions, get me on chat or email. Otherwise, we'll see you later.